Alright, now let us start with focusing on backend. Now you can see in the API folder we have two parts. At the API level we have dependencies main.py and schemas.py, and then we have a folder called as router, and in router we have analysis, memory, review and signals. Okay, so let us start with schemas. Now these are the schemas that we're going to define. This is going to define all the request and response shapes for every API endpoint. Okay, what is a schema? It's nothing but it's like a contract. It basically says that when you call this particular endpoint, send this particular data in this particular shape. Okay, without schemas our API responses are going to be chaotic. Okay, and we're going to focus on pedantic schemas, and with pedantic schemas everything is typed, which means every field has a declared value. It is validated, which means pedantic rejects wrong types immediately with clear errors. It is sorry, it is documented. Oh, just a minute, something went wrong. All right, just give me a minute please. Let me just fetch the code. I think yeah, okay, this looks fine. Okay, all right, so now it is going to be documented, which means fast API reads these schemas and auto generates Swagger documents, and it is going to be serializable, which means pedantic converts to from JSON automatically. Okay, how fast API is going to use this? We're going to use every API endpoint declares its request and response schema. Okay, we're not going to run this directly. API main.py imports and uses these schemas. Okay, we're going to use base model, which is pedantic in nature, right? It's the pedantic base class, and fields lets us add default values, descriptions and constraints. Okay, and these descriptions are they appear in the auto generated Swagger documents. These are the request schemas that we are defining, which means what the API receives from callers. Okay, so first and foremost we're going to define pedantic analysis request. This is a request body for, you can see I've defined it here. It takes the task. Okay, and for example, now default I'm setting it to find the completed clinical trials with research integrity issues. I have defined the description, I've defined the example as well. Similarly, it takes the list of IDs for NCT IDs, it takes the max studies. Then the next is review decision request. Okay, and here now this is submitted by human analyst after reviewing a queued signal. Okay, it takes the decision, it takes the reviewer, it takes the rejection region and the editable summary. After request schemas, we're going to focus on response schemas, where we're going to focus on signal response, which is one signal in the API response. These are the fields that it is going to take into consideration. Here we have defined the configurable class. Then we have analysis response. It takes into these fields and consideration these particular fields. Okay, and then we have class review item. Now these things are very self-explanatory. We are just defining different schemas here. So we are defining it for revenue queue item, we are defining it for review queue response, we are defining for review decision response. Okay, episodic response. Okay, so now this is basically, now this is returned by, you can see get and the endpoint. If you see here, so we get the episode ID, agent name, NCT ID, content, outcome, similarity and created at. Similarly for the procedure store response, similarly for the sponsor profile response, and you can see all of them are pedantic in nature. Okay, health response, okay, which is just to check if it's a 200 okay, yes or no. After that we go to the dependencies part, which basically creates and manages the shared resources that the API endpoints are going to need. What is a fast API dependency? Dependency is nothing but a function that fast API calls automatically before running an endpoint. Okay, for example, you can see app.get signals, which means it is going to call in that particular endpoint. Okay, or a dependency you can say. Okay, we're also going to use LRU cache. LRU cache is basically the least recently used cache, and it makes a function return the same object every time it is called instead of creating a new one each time. If you are not using LRU cache, then let's say we are using this function, which is get HITL gate. It creates a new HITL gate on every API request, something that we don't want, right? Cool. So you can see from func tool we are going to import LRU cache. Okay, LRU cache is Python's built-in memorization decorator. This should be memorization decorator. Okay, let me just write decorator. Okay, it is applied to a function. It caches the results on the first call and returns the cached result on all the subsequent calls. Okay, from graph.hitl, you can see in hitl.py we have created. I'm going to import hitl gate, episodic store, procedure store, semantic store, graph. Okay, then here I'm going to define that LRU cache decorator. I'm going to call this function, which is hitl gate. What does this do? It returns the hitl gate instance. You can just see it just returns an instance. Okay, max size equals to 1 that we have defined here at LRU cache. This means that cache the result of the first call. Every subsequent call returns the same hitl object. Okay, and the hitl gate holds the database connection pool. We want exactly one pool. Yeah. Similarly, we are going to do it for episodic store. It returns the episodic, it returns the episodic store instance. Similarly, get procedural store, gives procedural store instance. Semantic store gives a semantic store instance. And finally, we're going to create a function called as get graph, which returns the complete LangGraph, or a complete LangGraph graph. Okay. Now, this get graph function is not cached with LRU cache, because Mosaic graph is already a module level singleton. It was compiled once in graph builder and importing it here basically gives us the same object every time, right? So that is where dependencies come into picture. Okay, so as of now we have defined the schemas, we have defined the dependencies. After schemas and dependencies, you just go to routers, and routers go to analysis. Okay, in analysis, what do we do here? Okay, this is going to handle the post. You can see this is the most important endpoint. Okay, this is the endpoint that triggers the entire analysis pipeline. And what will happen when we are going to call this particular endpoint? It receives the analysis task and parameters. It invokes the compile LangGraph with the new task, with the task. The graph runs all the 6 specialist agents in parallel. Your signals are processed through the hitl gate. The supervisor compiles the final intelligence brief, which means, what is happening here is basically it is working on the entire, invoking this endpoint is going to build or run the entire pipeline, and it returns the complete analysis. And this is the entry point for everything. Okay, everything that we have built. So from api.schemas, we're going to import analysis request, analysis response, get hitl gate, get graph, all of that. You can see here we're creating the router instance. Okay, then we're going to say router.post. I'm going to give the endpoint here. Now I'm going to say response model equals to analysis response, something that we have defined here. Now response model tells the fast API to validate and serialize the response using the analysis response schema. I've defined the summary here, I've defined the description, and tags as analysis. Okay, it takes into consideration an async function. Okay, I'm going to create this function called run analysis. Basis the analysis request hitl gate and graph, it is going to run it. It is going to trigger the entire analysis run. It is going to run all the 6 specialist agents. Okay, run ID is given a universally unique identifier. It logs the start time, and let's say I'm going to invoke the LangGraph setting this as the initial state, and basis this as the initial state, it is this is basically the initial state dictionary that gets passed to the first node. Okay, and every field in the Mosaic state must have an initial value here. LangGraph agent reads from this, and so this state is going to be shared across all the LangGraph nodes, and it is going to get updated. Okay, then we're going to use on the initial state that is passed, your entire graph is going to get invoked, and finally the result is going to get generated. Okay, then process the signals through hitl. So from this results dictionary, we're going to get the signals, else an empty list. We're going to create an empty list called as processed signals. Okay, and from hitl.get, we're going to apply this process signal function on the signal, and that is your hitl result. Okay, we're going to append the signal, which means the signals dictionary. We're going to unpack the signals dictionary here. Okay, that is going to get appended in your process signals empty list. Okay, and from the hitl result, we're going to get that action, and we're going to store that as hitl action. We're going to log it. We're going to look at the duration. We're going to log it again, and we're going to return the analysis response, which gives us the run ID, task, final brief, number of signals, which are the signals that are requiring review, which are low confidence, which are the agents that got activated, and what was the duration. Okay, so this was the analysis. I mean, you can just look at one single endpoint, at analyze endpoint, your entire pipeline is kind of getting ignited. Next we go to signals.py. Okay, in signals.py you are basically working with the next endpoint. This handles the signal retrieval endpoints. Okay, so you can see here signals, which is it is going to list all the signals, and signals ID, it is going to get one specific signal. Okay, so first and foremost, you can see here we are going to import API router, depends, HTTP execution and query. We're going to create a function called as getPool, which creates basically a direct async gpool for signal queries. So when we create a pool connection, these are the things that we get, which is host, database and password data. When we hit this particular endpoint, okay, this particular function is running. Okay, it basically gets run in the backend, which is list signals. These are the arguments it takes into consideration. What does list signal do? It is going to return all the signals from the signals table. Okay, it supports filtering by agent, signal type and status, and results the newest first. Okay, have we given any hard limit as of now? Okay, so it is basically greater than equal to 1 and less than equal to 200. Okay, so that is the maximum number of signals to return. Okay, we're going to create the connection. As of now, conditions, parameters and index, we're just setting it here. Then if agent, then to conditions we are appending whatever agent we're getting. All of this, I think we have already discussed all of these things. Okay, here we are just basically appending and updating the information either on the signal level. Now when we are appending this to the parameters list, this is the SQL script that runs in the backend. Okay, similarly, if you are specifically focusing on this endpoint, this is the SQL query that gets run in the backend. Okay, inside this particular function. So when we are running the get SQL method, async method, this is the SQL query that it is trying to execute. And finally, we try to close that particular connection. Okay, now the thing is, these things are something to be understood. You don't really focus on how did we build it. Just try to understand what are we doing here, what are the data, what is the data we're going to fetch. Similarly, we have the review part. Okay, here we are going to build two endpoints, review queue and review ID. Review queue gets us all the pending review items, and review ID submit a human decision. Okay, so you can see here review queue. Okay, you can see it accesses the review queue response. It gets the pending human review queue. I have defined the description here and the tags as well. It works on this async function, which is get review queue, takes HITL gate and returns all the signals currently in the human review, which is basically all the low confidence data. Okay, so you can see HITL.get review queue. Okay, you can see it is creating the connection here. Okay, and then pool.acquire. From the connection, we're going to apply fetch-val. Fetch-val is typically when we are depending on such kind of data. Typically when we are using count kind of this thing, when you want single value, you go for fetch-val. So as of now, I just want from HITL reviews where the decision is pending, approve and reject. So I get an individual count as to how many how many decisions are either in the pending stage, approval stage or rejection stage. Okay, we close down the pool connection here and it returns these things. Okay, next we go to the next endpoint, which is review queue ID. The response model it uses is review decision response. Given the summary here, given the description here, this is the async function it runs, which is submit review decision. Takes the HITL gate. Now it submits a human analyst's decision on a queued signal. Okay, whatever signal is queued, which has low threshold. Basis on that, okay, what is the human decision that is going to be given by this endpoint? If it's approved, then the signal is accepted. Edited, then the signal is corrected. Rejected, then the signal is rejected. Okay. If the request.decision is not in either of the three, it is going to raise that exception 4 to 2. Okay. Else, now it is going to say HITL.process human decision. It is going to work on these many internal parameters. Okay. So when from HITL get, when we are going to process the human decision, it is going to work on these parameters. It is going to take QID, decision, reviewer, rejection region and edit summary. If not, it is just going to give an exception error, and whatever decision gets, whatever decision, for example, request.decision, let's say the human says reject. Okay. It is going to update the memory. Okay. The memory updated here is true. If you see here, it is true when the decision was reject and the rejection region was provided, which means both the things should be true. Okay, both the things should be 1 and 1, only then the memory gets updated. You can see it is getting logged here, and what does it return? It returns the final response. Okay, with success equals to true, it gives you the decision, signal ID, queue ID, memory updated true or false, and the message. Which means now basis the human rejection, the procedural memory is going to get updated, right? The agent will reason differently in all the future sessions. Yes, and finally you're catching the exception here. The next is the memory part. In memory, we are again building different endpoints, memory episodes, which is going to search through all the past episodes. Then memory procedures agent name, it is going to get the agent rules. Sponsor name, it is going to get the sponsor profile, and sponsor is the list of all the sponsors. Okay, so you can just go through this. Okay, which is, you can see memory episodes. This is the async function it runs. It is going to take the query given by the user, description, agent name, default, all of that. Okay, these are the things that is going to work on. What does this function do? Get episodes. It is going to return the past agent reasoning sessions from the episodic memory, and that is what it is doing. You can see store.search episodes bases the query, agent name, and top k, whatever limit you are defining. Okay, you can see the limit here we have defined. Default is 10. It should be greater than 1. It should be less than equal to 50. Okay, if you are defining nothing, by default it will show 10. Else it is not going to give you anything. Okay. Basically it is just going to give you from the recent, not anything, sorry for that, it is going to give you from the most recent episodes. Okay, then we have memory procedure agent name, which is to get an agent's current reasoning rules. Okay, it runs get procedures in the backend. It returns all the current reasoning rules for the specific agent. Okay, so it shows both the default rules, which are the built-in rules, and the learned rules. What are learned rules? Learned rules are from the HITL feedback. Okay, basis that your procedural memory gets updated, right? So here you can see we are accessing the procedural store. Okay, what does it return? It returns the name of the agent. It returns all the procedure, which is all the rules, total number of procedure, total number of rules, default rules, and learned rules. It is going to give you a total of them. Okay, and the next API endpoint, which is sponsor name, this gets the sponsor credibility profile. So we're going to run an async function called get the sponsor profile. This returns the full credibility profile of a scientific research sponsor. Okay, it includes the credibility score, compliance history, all of that. Okay, so you can see from store, okay, which is your semantic store, it is going to get the sponsor profile. Okay, if not, it is going to raise the HTTP extension. Then we just have a sponsors endpoint, which is going to list all the sponsor profiles, and that is also it is going to get from the semantic store. So from the semantic store, it is going to get all the sponsor profiles. You can see it is going to get the sponsors and how many sponsors we have. Okay, all right, that brings us to the last part, which is main.py. And main.py is nothing but you are typically bringing all of this is the fast API application entry point, and this file is the one that interacts with the entire routing pipeline. This creates the fast API app with metadata. It defines the lifespan. Okay, it mounts all the 4 routers. It adds the middleware. Okay, and how to run it locally, I've given it here. Okay, and once it opens, you just go to 8000/docs, and here you can have access to Swagger UI. Okay, you can just go through this particular file. Now in this file, what we're doing is we're going to just bring all the endpoints together. We are using something called as async context manager. Okay, async context manager is something that turns async generator function into async context manager, which is used for fast API's lifespan pattern. What is lifespan pattern? It's basically startup and shutdown logic. Now, fast API's lifespan replaces the older app on event startup pattern. Everything before yield runs at a startup, everything after the yield at shutdown. Okay, and that is what we are doing here. We're creating a function called as lifespan. Okay, and which is going to use procedural store here, get procedural store, await. Now again, as I said, we are just bringing all of these things together. You can see we are just mounting all the routers here. Okay, then just a simple health check endpoint just to check if things are working fine or no. And when we do, finally what does it return? It returns just the status, healthy, the name of the app, version, DB status, and the details regarding the signals, pending reviews, all of them. This is the root endpoint function. That's all. That is typically what main.py function we are defining here. All right. Cool, guys. So that was around the backend of this particular pipeline, the fast API backend. Okay. Let's proceed with the next part now.